This system is called SS because the acronym stands for Shoring Foundation, said the STM. SFS Structures Limited, based in Calgary, Alberta, invented and patented this original system in Canada. This system initiates excavation and protects the perimeter slopes. It also functions as a retaining wall, preventing damage to neighboring properties. Additionally, it removes the need for temporary shoring systems or anchors, which are generally not permanent retaining structures. A permanent retaining wall is often necessary when such temporary systems are employed. The provisional systems used so far include the Berlin Wall, diaphragm wall, shoring system Minan Wall, and mud wall. These systems are frequently very costly and specialized. The first step is to position a hollow structural steel HSS section, which will be part of the new building's structural columns. These columns extend more profoundly than the bottom of the lowest parking level. In other words, they are placed according to the final structural design. At this stage, the excavation process has not yet begun. Only the drilling required to install the perimeter and central columns has been completed. As shown in this diagram, we proceed with the excavation once the HS steel elements have been positioned according to the center lines of the final structural columns. On average, 1.5 meters of vertical cut can be made at a time. As the excavation progresses, the prefabricated elements developed by SFS are gradually installed. These elements consist of reinforced precast concrete panels designed for each project based on soil type and general conditions such as seismic activity, water table level, proximity, and neighboring structures. Additionally, the base of the HS elements is embedded in a concrete pile, which is also designed according to soil mechanics and geotechnical conditions. This diagram illustrates how the precast panels are installed and secured to the perimeter HS elements as the excavation progresses. This process helps stabilize the neighboring slope, preventing potential failure. It is crucial to note that this system does not require anchors extending beyond the property line. Such anchors typically have a high failure rate, as the soil in which they are placed may not be stable. Additionally, obtaining the neighbor's authorization is necessary, and in most cases, they demand significant financial compensation. All these challenges are effectively addressed by using the SFS system to retain walls. Once the first row of curved precast panels has been installed, the next row below it is placed. Since the first row is secured, it remains in position and does not slide downward. As shown by the end of the process, the HSS steel elements will be fully integrated with the precast panels, forming composite columns. Due to the curved geometry of the SSS panels, the system works primarily in compression. Additionally, depending on the magnitude of the load transferred from the superstructure to the foundation, the central steel columns can also be converted into composite columns. The entire system is designed by highly qualified experts in geotechnical and structural engineering, who coordinate with the architect and structural engineer involved in the project. Our technical teams typically comprise PhDs in structural engineering, PhDs and master's degree holders in soil mechanics, and experienced professionals specializing in precast systems and excavation processes. When constructing a parking structure or a basement with more than 2 levels, the perimeter columns must be integrated into frames with the central columns. This prevents the perimeter HS elements from acting entirely as cantilevers. As shown in this diagram, the process of forming frames with the interior columns progresses as the excavation advances and the precast panels are installed, as explained in the previous slides. A perimeter beam is installed at each level where a parking slab will be placed, or at a maximum spacing of 4 meters depth. This beam integrates with both the precast panels and the composite columns. The concrete placement is carefully executed to ensure full integration of the columns, panels, and perimeter beam, resulting in a highly rigid structural element with significant load-bearing capacity. As previously explained, the system works with the central columns and extends to the opposite end of the excavation, ensuring complete stability of the entire structure. These steel beams, which form structural frames, will later become an integral part of the parking slab structure. In other words, we are using the same beams that will ultimately be part of the final structure as formwork, achieving remarkable cost efficiency. This eliminates the need for any temporary shoring system, which is still required in practically all other methods used today. As the parking structure's slab sections are completed, the SFS joist slab system is installed. As the name suggests, this system consists of specially designed steel joists that become an integral part of the slab's structural system. One key advantage of the SFS joist slab system is that it does not require scaffolding or temporary shoring. The process has been engineered to eliminate the need for posts or support towers to hold the concrete during the curing of the compression layer. This system is similar to the Q-deck or steel deck system. But unlike these methods, the SFS system does not require metal decking. As a result, it achieves floor slabs that are 84 kilograms per square meter lighter than solid slabs or Q-deck systems. Additionally, it is more cost-effective and faster to build, reducing construction time by an average of 25% compared to conventional systems. Moreover, the SFS joist slab system is 100% green, as it does not require wooden posts to support the concrete during pouring. Beyond being a lighter system, it offers significant advantages in construction efficiency. Just one day after the concrete is placed, work can begin on other areas, such as wall layout, electrical system installation, and plumbing setup. In contrast, traditional methods typically require 15 days before additional work can proceed. The joist slab system is assembled according to the structural design. However, it requires significantly less rebar due to the presence of the steel joists. The final design will depend on factors such as the expected load levels, the span between columns, and of course, compliance with local building codes, including seismic analysis requirements based on the project's location. Phenolic plywood is used between each joist, which can be reused over 40 times. This is possible because it is treated with special protective additives and is never drilled or screwed into any component. This provides a significant cost advantage for the project, making it more economical and environmentally friendly. Additionally, it allows construction to proceed with a minimal number of plywood sets, even for buildings of 20-30 floors or with substantial floor seal savings in both time and materials, at least 25% lower than traditional methods. It is also important to note that this method does not require corrugated metal decking. as is the case with conventional steel deck systems. The floor slabs will also contribute to the overall stability of the SFS retaining wall system. They will act as diaphragms, enhancing structural integrity while simultaneously serving as the floor system for both the parking levels and the superstructure. The floor slabs will also stabilize the perimeter retaining walls. In this slide, the SFS systems are working simultaneously, enabling a speedy construction process. This is possible thanks to the loop-down system, a method developed and patented by our collaborators. Over time, the original name has been altered, and many professionals now refer to it as top-down, which is a wholly incorrect and misused term improperly derived from our original loop-down system. We can provide a detailed explanation of this method in a separate presentation. Here, you can see real project photographs showcasing our systems in action. These systems have demonstrated outstanding performance, which is why we are actively promoting them. Thank you very much for your time and attention.